And welcome to Cambridge Chemistry channel with Sarwat Ahmed. Today I will be solving second part of question paper 1-1 from 2019 June 9701. So let's start. Question number 20. The diagram shows two different compounds. What is the total number of structural isomers including compound 2 that could be formed by adding a second methyl group to the ring of compound 1? The number of pi electrons in each compound. Number of pi electrons are there are two double bonds. The number of pi electrons are 4. Double bond, number of pi electrons are 4, and this structure is H1 2 3 4 1 2 3 and 4. This is hydrogen, this is carbon, 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 5 and 6. So there are 6 carbon, 7 is this is methyl group, and 1 2 3 1 methyl. There are 5 positions in which methyl is replaced by H. It can be over here, it can be over here, over here, 1 2 3 4, and on this position. So there will be 5 isomers and 4 pi electrons. Five number of isomers and 4 pi electrons. Question option is D. Which compound has the molecular formula C6H10O? C6H10O. 1 2 3 4 5 6. C6H 1 2 3 H 1 2 3 4 5 6 7 8 9 10. C6H10O and carbon, carbon, carbon and carbon. One, 2 3 4 5 and 6. 1 2 3 4 5 and 6. C6 1 2 1 2 3. This is hydrogen, 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 hydrogen. 1 2 3 4 5 6 7 8 9 10 11 12. C6H12O. This is wrong. carbon H 1 2 3 4 5 6 C6 1 2 3 4 5 6 7 8 C6H8O and 1 2 3 4 5 6 C6 H 2 hydrogen atom. So 1 2 3 4 5 6 7 8 9 10 11. So this is C6H11O. So this is also wrong. So A option is correct, which has C6H10O formula. Question number 22. What is the structural formula of the major product when hydrogen bromide reacts with 2-methyl but2E? HBr react with 2-methyl but2E. This is the compound. Two-methyl but2E. Hydrogen bromide react with HBr. CH3HBr. So the compound is CH2 Br CH3 CH2 this is CH2 C C H Br CH3 CH2 and CH3. 1 2 yes. This is not correct. CH3 twice CBr and CH2 CH3. This might be correct. B option must be correct. CH3 CH2, this is not correct because so this is not correct. CH3 twice CH CHBr and CH. This is not correct. And this is the last one is so Br is present at the terminal, which is not possible because the reactant is this, in which butene over here, it can be like this: CH3 twice CH CH2 CH CH2. So this is the this is not possible. CH2 and CH2Br. It is not major product. It is minor product. So this is not correct. B must be correct. Which reaction is most likely to involve the formation of a positively charged intermediate? 1-bromopentane. C 1-bromo H2 H2 CH3 with warm dilute sulfate. This is the primary alcohol, formation of primary haloalkane so, and the reaction is SN2 like this. H takes place in one step and so carbocation cannot form like this. CH2 C4H9. So the OH ion attached, and this is the intermediate OH, CH, H. This is intermediate C4H9. So this is not correct. Next, B is 1-bromo 2,2-dimethyl propane and warm dilute nitric acid, sodium hydroxide. This is propane 2,2 CH3 CH3 CH3. Two dimethyl propane. So this is again primary haloalkane, SN2 reaction in one step, and there is no intermediate positively charged cations. So this is also incorrect. Next compound is 1-bromo 3-methyl butane. Br CH3 H. This is also primary haloalkane, SN2 reaction will not form a positively charged intermediate. So this is also incorrect. So D must be correct because 2-bromo 2-methyl butane, 2-bromo 2-methyl 2-bromine 2-methyl CH2CH3. This is tertiary haloalkane. Exhibit SN1 reaction. Which takes place in 2 steps. First step is slow step, like this. Partial negative, partial positive. CH3 C double positive carbocation, CH3 and CH2 CH3. This is step 1. And this is step 2. Slow step, rate determining step, and second step 2 is fast step. To form CH3 OH CH2 CH3. So A must be D must be correct. Question number 24. The infrared spectrum of a substance with empirical formula C2H4O is shown. Which bonds are responsible for peak X and peak Y? Peak X is C double bond O, and at two 28 to 100 to 23,000, peak is for CH peak. This is CH peak at 2800 to 3000. So this is CH peak, and CC peak is not CH peak 010. So B must be correct. Question number 25. The structure of quinine is shown. Quinine can be synthesized by reacting ammonia with a dibromo compound X. What is the name of the compound X? Br2, C8H16Br2. The compound X must be like CH2, CH2, CH3. This is the beer, beer. So when reacting with NH3, it is like this. This is 1, 2, 3, 4 and 5. It is 1, 5 dibromo, 6, 7 and 8 dibromo octane. So D option must be correct. 1, 4 is not possible because 1, 4 bromine over here or bromine over here. So this is not possible. Structure 1, 2 dibromo. This is also not possible. 1, 2 dibromo is not possible. Structure. So this is also incorrect. 1, 1 dibromo. No. So it is also incorrect. Only D option is correct. 1, 2, 1, 5 dibromo. Next question, structural isomerism and stereoisomerism should be considered when answering this question. 3-methyl hexane 3-ol reacts with hot concentrated sulfuric acid to form several isomeric compounds with the molecular formula C7. Several compounds with the C7H14. 3-methyl hexane 3-ol. One possibility, this is structure CH3, CH2, C, CH3, OH, CH2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. CH3. How many isomeric compounds could be formed in this reaction? Concentrated sulfuric acid react with concentrated sulfuric acid plus H2SO4. So CH3, CH double bond C, CH3, CH2, CH2, CH3. This is one possibility, and this is one structural. And cis trans also cis trans isomer like this CH3 CH3 CH2 CH2 CH3. CH3H CH3 cis trans and cis CH2 CH2 CH3. So exhibit 2 structure over here, and there is another possibility. This structure exhibit 2 isomer, and there is another possibility CH3 CH2 C double bond CH2 CH2 CH3. This is structural isomer CH. Structural isomer, and another possibility is CH3 CH2 C double bond CH3 H CH2 and CH3. So in this isomer also cis trans isomer CH2 1 2 3 4 5 6. Yes, CH3 2 more, and this is the structural isomer. So there are total 2 cis trans over here, 2 possibilities, and 2 and 2 4 and 1 5. C option is correct. An organic compound T undergoes the following reaction. T is oxidized by hot acidified potassium manganate. 7. T reacts with sodium to give hydrogen. T is oxidized by acidified potassium manganate 7. What could be the T? CH3 CH3 CH2 C hot acidified potassium manganate H OH CH3. This will give CH3 C double bond O, ketone is formed. T reacts with sodium to give hydrogen. Yes, it also gives CH3 CH2 CH CH3ONA. So react with hot acidified potassium manganate as well as react with sodium to give ONA compound is formed plus hydrogen gas. So next compound is CH3. This is aldehyde and it gives 1 2 3 4 butanoic acid, CH3 CH2 CH2 CO2H, and butanoic acid will not react with sodium to give hydrogen gas. T is oxidized by hot acidified potassium manganate 7 and but it does not react. Aldehyde will not react with sodium, so this is incorrect. C option is CH3 CH3 CH3. This is tertiary alcohol which is not oxidized further. But can react with sodium to give hydrogen. React with sodium. ONA. So this is also incorrect. This is ketone which is not further oxidized. Neither react with sodium. So this is also incorrect. A option must be correct. Question number 28. Compound X is treated with the two reagents successively forming compound Z. CHO, CO, CH3 and O. Mild oxidizing agent to produce COCH3, and this is CO2H. Further react with NaBH4 to form CHOH, CH3 and CO2H. NaBH4 does not reduce carboxylic acid. Lithium can reduce carboxylic acid CO2H to alcohol. So A must be correct. So CH2OH, this is not correct because NaBH4 does not reduce carboxylic acid. This is also incorrect because no effect NaBH4 does not react with double bond. So this is also incorrect. CO2H CH OHCH3. This is correct. But double bond does not change, so it is also incorrect. A option must be correct. Which reagent may be used to distinguish between propanol and ethanol? Propanol and ethanol. 2,4-dinitrophenyl hydrazine will react with propanol but does not react with ethanol. No change with ethanol, and react with propanol. Gives positive test with propanol. So this must be correct. Bromine water cannot differentiate propanol and ethanol. Failing reagent also no reaction with propanol and ethanol both, and not with tolerant reagent. Which compound is chiral? Which compound is chiral? 1-chloro. This is butane. 1-chloro Cl 3-methyl. H2C CH2. This is not chiral as this carbon is not surrounded with 4 different groups, 2H, and this carbon also is not chiral as carbon 1 and carbon 3 are not surrounded by 4 different groups. 4 different groups. So this is not chiral. Now come to the B, 2-chloro butane, 2-chloro Cl 2-chloro 2-methyl CH3 CH3 CH2 CH3. This is again not chiral because this carbon will not surrounded by 4 different groups. 2CH3, this carbon is surrounded by 2 same groups, so it is not chiral. C 2-chloro 3-methyl this is HCH3. This must be chiral. This carbon because this carbon is surrounded by 4 different groups. This carbon is chiral because this carbon is surrounded by 1 chlorine. This is CH3, this is H, and this is whole different groups CH3. So this must be best option. 3-chloropentane. One, two, three. So this is again not chiral because this carbon surrounded by CH2 two same group, so this is also incorrect. Question number 31. An atom of a calcium 48 can form two positive ions. Which statement about this ion are correct? 48 calcium mean 20 proton and it has 20 proton. It is correct. It has 28 neutron. 48 minus 20 is equal to 28 neutron. It is also correct. It has 22 electrons. It carrying 2 plus charge. It could have 18 electrons after losing 2 electrons. So it is not correct. 1 and 2 are correct. Then option is B. Which formula represent four elements W, X, Y and Z have electronic configuration as shown? Which formula represents the compounds that have boiling point below room temperature? That must be below room temperature. Boiling point must be below room temperature. This must be any gas. WX2, this is group 6 and this is group 4. If 2 and 4, then this is carbon and it is oxygen. So CO2 is formed. So this is gas and its boiling point is below than room temperature. So WX2. So if W is carbon and X is oxygen, then it is correct option. YX formed because X is non-metal and Y is group 2 metal, so it is ionic compound and its boiling point is not below than room temperature. It is ionic compound. Boiling point is not below than room temperature. It is incorrect. And Z2X. Z is again metal and X is non-metal ionic compound. So this is also incorrect. So D is best option. Which statement about enthalpy changes are correct? The enthalpy change of atomization is always positive. Yes, it is correct. The enthalpy change when CC bond is broken is positive. Bond breaking is positive, endothermic, so it is also correct. The enthalpy change of neutralization of weak acid is always negative. Yes, this is also correct, because enthalpy change of neutralization is exothermic, which is always negative. So this is also correct. 1, 2, 3 are correct. The option is A. Vanadium and pepsin can both act as a catalyst. Vanadium is a metal, pepsin is an enzyme. Which statement are both correct for both vanadium and pepsin? They will speed up any chemical reaction. So they will not speed up any chemical reaction because enzymes and catalysts are very specific in nature. So this is incorrect. They can lower the activation energy for, yes, this is correct for both vanadium and pepsin. They are not used up when they act as a catalyst. So catalyst only speed up the reaction without using itself. So it is also correct. If 2 and 3 are correct, then option is C. Question number 35. Which oxides when placed in cold water for 1 day will react with water? Magnesium oxide is almost insoluble, but when placed in cold water for 1 day will react with water. So magnesium oxide is correct. It is insoluble and it is also insoluble. do not react with water. So this is incorrect. If one statement is correct, then option is D. Question number 36. A mixture of magnesium carbonate and magnesium nitrate is heated strongly in a hard glass test tube. Which gases are formed? Magnesium carbonate gives magnesium oxide plus carbon dioxide. Magnesium nitrate gives magnesium oxide plus nitrogen dioxide plus oxygen gas. So carbon dioxide is correct, nitrogen dioxide is correct, oxygen is correct. If three statements are correct, the option is A. Which statement about polyalkenes are correct? Polyalkane do not react with bromine in the dark. Yes, it is correct. Disposal of polyalkene is by combustion can produce harmful products. Yes, polyalkene produces carbon dioxide and water which are harmful. So this is also correct. Polyalkene do not readily biodegradable. Yes, this is also because this is synthetic polymer, so it is non-biodegradable. So 1, 2, 3 are correct. The option is A. Question number 38. Compound Y reacts with alkaline aqueous iodine to form a yellow precipitate. Changes the color of warm acidified potassium dichromate solution. What could be the compound Y? CHOH gives positive test with alkaline aqueous iodine. So this is incorrect. First option is incorrect because this is CH3 CH2OH. This is primary alcohol and this will not give the positive test with alkaline aqueous iodine. Only changes the color of warm acidified potassium dichromate. One test is correct, but this is incorrect. So in this case, this is incorrect statement. This is CH3 aldehyde. This also gives positive test when react with the alkaline aqueous iodine to form a yellow precipitate, gives yellow precipitate, and also changes the color of warm acidified potassium dichromate solution because it changes into carboxylic acid. So this is correct. CH3, this is ketone. So this will give the test positive, react with alkaline aqueous iodine to form a yellow precipitate. Sorry, it will gives this is CH3 CHOH. This will give positive test. Sorry, this because this OH attached with CH3, so it will give CHI3 and also changes into carboxylic acid CH3COOH and changes the color of warm acidified potassium dichromate solution as well as react with alkaline aqueous iodine to form yellow precipitate. So 1 and 2 are correct. This is incorrect because it only gives the positive test while reacting with alkaline aqueous iodine to form a yellow precipitate. It gives yellow precipitate CHI3 but does not change the color, change the color of warm acidified potassium dichromate solution. So this is incorrect. If 1 and 2 are correct, then option is B. Question number 39. Carboxylic acid can be made by several different reactions. Which statements are correct? The acid hydrolysis of CH3CH2CN will make ethanoic acid. No, this is incorrect because it will make propanoic acid CH3CH2CO2H. The option 1 is incorrect. The oxidation of CH3CH2CH2OH will make butanoic acid. 1, 2, 3, 4. Yes, it will form butanoic acid. CH3CH2CH2 it will form butanoic acid CO2H. So this is correct. The oxidation of CH3CH2CHO will make propanoic. Yes, this is aldehyde and the oxidation of this compound gave propanoic acid CH3CH2CO2H. This is also correct. If 2 and 3 are correct, the option is C. Question number 40. Carboxylic acid react with alcohols to produce esters. Carboxylic acid X forms one ester only with molecular formula C5H10O2. What could be the X? Ethanoic acid when react with propanoic acid. Propanol CH3CH2CH2OH. This will give two compound, one with this CH3COO CH2CH2CH3. So this is primary alcohol. This could be secondary alcohol as well. So there are two types of compound. If primary alcohol with this and this is secondary alcohol, and this compound, second compound is CH3COO CH3 and CH3. There are two types of compound are found which have C5H10O2. C5H10O2. But in this case, this is incorrect. Propanoic acid react with ethanoic acid CH3CO2H to form ethanol CH3CH2OH. So this will be formed CH3CH2COO CH2, CH3. Only one compound will be formed whose formula is C5H10O. And butanoic acid plus methanol, CH3OH, no other compound, no other structure is with methanol, so only one compound is formed, CH3, CH2, CH2, COO, CH3, methyl butanoate. So with formula C5H10O, only one product is formed, one type of product is formed. So this is correct, 2 and 3 correct, so option is C. So this is all about of this paper. If you like this video, please like, share and subscribe this channel.